Open up your book to page 223. Today we're going to be doing lesson 16, and lesson 16 is about a type of rate that is called speed. Now, a rate is just a ratio because it is a comparison of two quantities. When it comes to speed, it's a comparison of two quantities that have different units. There's always a unit of distance and a unit of time. So speed is always a ratio of distance over time. So you're always going to have a unit of measure for distance and a unit of measure for time. And it's basically just a ratio that we call a rate. So if you ever heard anyone say, what is his rate of speed? They're talking about how fast they're going. Now this first section, we're going to skip that. I can't write in those little bitty boxes, but we'll talk about it in class. Everybody look at number 2. A squirrel runs at a speed of 12 miles per hour. Complete the table that shows the number of hours and the number of miles the squirrel runs at that speed. Well, this is just a ratio table. 1 hour, 12 miles. 2 hours, 24 miles. 3 hours, 36 miles. 4 hours, 48 miles. Super easy. It just went in consecutive, the number of hours went in consecutive order. And then the number of miles are just multiples of 12. And it is miles per hour. So if you look back at what I wrote here, where I said that speed is distance over time, the unit of measure that we used for distance for number 2 was miles, and the unit that we used for time was hours. So when we go down here and it asks us for a speed, we're going to give it in miles per hour. Let's look at number 3. A house mouse runs at a constant speed. It runs 4 miles per hour. Per means for every one. So that's for every 1 hour. Slower than the speed a squirrel runs. Determine the speed the house mouse runs in miles per hour. Use the speed the squirrel runs from problem 2. Well, we know that the squirrel ran 12 miles per hour, and then the house mouse is 4 miles per hour slower, and 12 minus 4 is 8. So the speed the house mouse runs is 8 miles per hour. Interpret the meaning of the speed the house mouse runs. That just means that the house mouse runs 8 miles for every 1 hour. All right, number 4 says, when a peregrine falcon dives to catch its prey, it's the fastest animal in the world. Well, there you go. If you were wondering about which one of those was the fastest animal, it is the peregrine falcon. The ratio table shows the number of seconds and the number of meters the peregrine falcon dives at a constant rate. This time, our unit of measure for distance is number of meters, and time is seconds. So we're talking about the number of meters per second. So if I'm looking at this table, I got to fill out this spot that's across from 1. Well, look at underneath there. You can see 2 is half of 1. So all I have to do is half 176 to get this spot, because all we did here was divide by 2 to get 1. 2 divided by 2 to get 1. So 176 halved, which is the same thing as divided by 2, is 88. B says, what is the speed the peregrine falcon dives in meters per second? The speed the peregrine falcon dives is 88 meters per, that means for every 1 second. That's a C right there, sorry. Once again, my mind's going faster than my hand. 88 meters per second. That's, wow, that's really fast. All right, C says, interpret the meaning of the speed the peregrine falcon dives. So basically, the peregrine falcon dives 88 meters for every 1 second. So as you can see now, in B, we use per. In C, we use for every 1. Per and for every 1 are interchangeable. They mean the same thing. All right, let's look at number 5. The slowest animal in the world is a sloth. The double number line shows the number of meters and number of minutes a sloth crawls at a constant speed. You can look over that double number line. Determine the speed the sloth crawls in meters per minute. All right, so if I want to get the number of minutes down to 1, 2, 3, and across my 3, all I need to do is take the 16 and divide it by 4, and that gives me 4 meters in 1 minute. So I can put a 1 here and a 4 here. The speed the sloth crawls is 4 meters per minute. All right, so to get down to 1 minute, we just divided both 4 and 16 by 4, which end up just being 16 divided by 4. B says, interpret the meaning of the speed the sloth crawls. Well, just like we've been doing, we're going to replace the word per with for every 1. The sloth crawls 4 meters for every 1 minute. Let's look at number 6. Number 6, we have a double number line, and now we're talking about speed, distance, and time. The double number line shows the number of miles and the number of hours a hummingbird flies. How many miles does the hummingbird fly in 5 hours? All right, well, you know 1 hour, so just extend that number line so that you can include the 5 hours. You know how to do this. You've done this before. So all you have to do is multiply 1 by 5 to get that 5. Then all you have to do on this side is multiply 30 by 5 to get what goes across from 5. So 30 times 5 is equal to 150 miles in 5 hours. All right, so 150 is what goes across from 5. Part B says, how many hours does it take the hummingbird to fly 45 minutes? All right, well, let me go back to my double number line. I'm going to have to make some room, so I'm going to erase this. Not highlight it, erase it. All right. So 45 is right in the middle of 30 and 60. I know this because if I did 30 plus 60, I get 90. And if I divide that by 2, I get 45. So right in the middle of 30 and 60 is the 45 miles mark. And let me go check to make sure. It says, how many hours does it take the hummingbird to fly 45 miles for B? So right in the middle of 1 and 2 is where that line lines up with. And of course, right in the middle of 1 and 2 is 1.5. So that would be 1.5 hours. So down here for part B, the answer is 1.5 hours to fly 45 minutes. I'm sorry, to fly 45 miles. Can't do that. Speed is distance over time. I couldn't say minutes and hours. It's 45 miles. 1.5 hours to fly 45 miles. Okay, then C says, how many miles does the hummingbird fly in 30 minutes or half of an hour? All right, go back up to our double number line. And we can see that we want to know 30 minutes. Well, half of an hour is right in between 0 and 1, which is going to be your 30-minute mark, right? So half of an hour. And then right in the middle of 0 and 30 is 15. So the hummingbird flies 15 miles in 30 minutes. All right, now D says, how many miles does the hummingbird fly in 1 minute or 1/60th of an hour? So to figure out 1 minute, we divide 1 by 60 and get 1/60th of an hour. So if 1 minute is 1/60th, then the number of miles is going to also be 30 divided by 60, because we divided the 1 by 60 to get a minute, which is 1/60th of an hour. So now we got to divide the 30 by 60. We divided the 1 by 60. Now my pen's not working. Anyway, you know that we're dividing the 30 by 60. So 30 divided by 60 and that's 30 miles divided by 60 is actually 1/2 of a mile. So 1/60 of an hour is 1 minute. So the hummingbird goes half of a mile in 1 minute. All right. Seven says a horsefly flies 70 kilometers in 30 minutes at a constant speed. Create a double number line. Hold on. All right, I'm just trying to get some room here. All right, create a double number line to determine the number of kilometers the horsefly flies in 150 minutes. So we're going to do our 2 lines. And this top line is going to be the number of kilometers. Remember, I'm just putting kilometers, but you understand that it is the number of kilometers. And then the bottom line is going to be the number of minutes, distance over time. It's a double number line, so we always start with 0 minutes, 0 kilometers and 0 minutes. It says 70 kilometers in 30 minutes, so we'll do 70 here and 30 here. All right, well, we can just, since it's a double number line, go in consecutive order. We are counting by 70s on the top line and counting by 30s on the bottom line. So my next line is going to be 140 over 60, just multiples of 70 and multiples of 30. Then 210, because 70 times 3 is 210. 90, because 30 times 3 is 90. And then 70 times 4, 280. And then 30 times 4 is 120. And then we'll go one more and say 70 times 5 is 350. And then 30 times 5 is 150. Now, I'm sure you didn't write all over your words on your workbook. I just have to because of this weird stylus I'm using. So I'm sure you can still read yours. But it basically says, the question was, what we had to determine was the number of kilometers the horsefly flies in 150 minutes. So I go look at my double number line and I see across from 150 minutes is 350 kilometers. So the horsefly flies 350 kilometers in 150 minutes. All right. Now C says, what is the speed the horsefly flies in kilometers per hour? So of course, 60 minutes is an hour, and across from 60 minutes, we got 140 kilometers. So the speed the horsefly flies is 140 kilometers per hour. See how we're using our tool, our double number line, to answer all these questions? Now it says, D says, what is the speed the horsefly flies in kilometers per minute? So that's 1/60th of an hour. So I'm going to have to divide, since I divided the 1 by 60, 60 minutes, 60 over 60, 1 hour. I got to divide the 140 by 60. So it's 1/60th of an hour. So that's going to be, so we're going to do 140 divided by 60, which when you do the math, you can see it's 2 wholes and 1 out of 3 left over. So it's 2 1/3. So because the horsefly flies 70 kilometers in 30 minutes, which ends up being 140 kilometers in 60 minutes, it flies 2 1/3 kilometers per minute. All right, now let's do some comparing ratios and rates. Ryan goes to a movie with his friends. He spends $24 to buy 4 buckets of popcorn. A, what is a ratio that relates the number of dollars Ryan spends to the number of buckets of popcorn he buys? Well, that's going to be 24 to 4, because a ratio that relates the number of dollars Ryan spends, $24, to the number of buckets he buys 4 buckets for $24, is 24 to 4. What is the rate in dollars per bucket? So here we're using the word rate. Rate is a ratio, but in a rate, one of the numbers is 1. So I can figure out, because it tells me how much he paid for 1 bucket. So what I want to be 1 is what comes behind per. So to do that, to get 4 to be 1, I got to divide 4 by 4. So for the number of buckets, I can do 4 divided by 4. That'll give me 1 bucket. And then the number of dollars is going to be 24 divided by 4, which is going to be 6. So if Ryan spends $24 to buy 4 buckets of popcorn, then he spends $6 to buy 1 bucket of popcorn. So the rate is $6 per bucket. Number 9 says Lisa checks the nutrition facts on a bag of granola. There are 2 grams of protein for every 1 serving of granola. What is the rate in grams of protein per serving? So remember, a rate is a ratio where one of the parts of the ratio is 1, and the one that you always want to be 1 is the one that becomes behind the word per. So if I'm looking for the rate in grams of protein per serving, I want the number of servings to be 1. Well, I can look right here and see it says 2 grams of protein for every 1 serving. Let me see if I can highlight that. That'll be better. 2 grams of protein for every 1 serving. So there we go. There's our grams of protein per serving. Well, that was easy. They just gave you the answer. So the rate is 2 grams of protein per serving. And I'm about to run out of room, so I'm just going to leave it at that. You spell out the word, please. All right. B says the ratio of the number of grams of protein to the number of cups of granola is 32:4. What is the rate in grams of protein per cup? So now I want the 1 to be the number of cups. In my original ratio, the number of cups is 4. So I've got to divide 4 by 4 to get that 1 that I want for the number of cups. And then, of course, if I divide the 4 by 4, I got to divide the 32 by 4 to get the number of grams of protein. So for the number of cups of granola, I'm going to do 4 divided by 4, get that down to 1 cup of granola, and then the number of grams of protein and of course, let me just put right here, this is cups and this is going to be protein. All right, so the number of grams of protein is going to be 32 divided by 4, which we all know equals 8. So the rate for the number of cups of granola per the number of grams of protein is 8 grams of protein per cup. 8 grams of protein per cup. And that is lesson 16.